Okay, so storage and file structure. So what is there in the chapter 10? We are referring to that database systems concept book. So what we have seen that how to overall that design more of the logical and conceptual modeling of the databases, and also looking into the queries based on the things. So at looking at the back of the thing, right, how the physical storage media or how the physical storage of the database files are there, that also plays an important role, especially when the database size is pretty large and there are a lot of access into the database, right? Specifically large transaction databases like banking, or even our things like our ERP systems, where the data accesses are pretty frequent and very and random and pretty large, right? So the major challenge is that we cannot bring the whole data into the main memory. So we need to have a lot of disk access, right? To just as already you know, just for the sake of completion, we have different type of physical storage media, like some are volatile and some are non-volatile, and there is a distinct hierarchy. Like if we say main memory, then down the line we have hard disk, then flash disk, uh, there are tape storage, optical storage, and plate tape storage, and things like that. And our traditional hard disk system, though these days with proliferation, large proliferation of SSD, that solid state devices, so this sort of our traditional hard disk are going um, are phasing out slowly. Nevertheless, so what we have different disk platters or different this cylinders. So these that particular cylinder have different platter. Every platter has different tracks, and the tracks has a that sector. Right? So in other sense, our if we want to access, want to have a good access rate or that ease of accessibility. So what we required, ideally your nearby data or all the records of a particular say relation should ideally should be in the same sector or nearby sector in the same platter, right? So this head movement can be reduced, right? So that the head movement can be reduced. So those are the things what we need to uh, look into the things. Right? Now that we cannot dictate, because finally not only the database management system that storing the file in some structure, it is finally taken care by the memory management or flight management system of the OS. Right? Though in case of pretty large databases, which do not rely or do not depend on the full operating system, they comes with their own file management, and the operating system do support that. Right? So there are issues in these cases. So what we see, uh, so that we have magnetic disk, so positioned very close to the data surface or more touching it, and that read write head. But these are the things. What are the read write heads? Surface of the platter divided into circular tracks over 50K to 100K tracks per platter on typically on the hard disk. Each track is divided into sectors. Right? So and typically sector size is 512 bytes. And ideally, if you see that when we read, we may be reading a chunk of the from the thing, and that basically is what we do, that sort of a block of data is being read, right? And that is also typically 512 bytes. So that in every read-write operations, between this magnetic disk or from the external disk or the hard disk to the memory, it can be in a block of data, right? So typical sectors per track is 500 to 1000. So read-write disk arm swings to the position of the header or the right track, pattern spins continuously, and it reads that particular sector, right? So it finds that. So so this is the way it works, and already you know this. Right? So there is a disk controller which interfaces between the computer system and the disk drive hardware, right? Accepts high-level commands to read and write in the sector, initiate actions such as moving the arm to the right track and actually reading the data, and have other type of other things like computing, attaches checksum sector to verify the data is read back correctly and things like that. If the data is corrupted with say that checksum retransmitted retransmission has to be there, and checksum recomputation things like that. So ensure successful writing by reading back sector after writing it, and performs remapping of the bad sector if there are bad sectors don't need to be. So and regarding the performance, again these are things what we know. There is the access time, the time it takes from when a read or write request is issued when the data transfer begins, consists of one seek time it takes to the position of the arm over the correct tracks, and rotational time it takes the sector to be appear before the or under the this your reading head. Data transfer rate, the rate at which the data is transmitted, typically 25 to 100 Mbps rate is there. There are higher rate these days what we are getting. So what we see that overall performance of the database query processing also depends in a big way with that how your overall disk is managed, right? So not only that the performance metric of the disk, there may be issues of how this how you organize the things, right? Like if a data if the for a database, if the data is spread over the different platter or across the separate disk, then it may take much more time than there, right? It may take more time than if it is properly arranged, right? So, so there are challenges in how you organize the things, and not only that, what we will see that if your record length is variable, how to fit into the in the disk sector or in the block, right? So we have a definition of this block, say a contiguous sequence of sectors from a single track. So I say block of data. So data is transferred between the disk and the main memory in blocks. Size ranges from 512 to several kilobytes. If it is 512 and the disk sector is 512, so every the data block what it is accessed between disk and main memory are sector wise. Otherwise, it is multiple of sectors, right? So smaller blocks, more transfer disk, larger blocks, more space wasted due to the partial field blocks, right? So so you need to have a optimize things. So typical block size ranges from 4 to 16 kilobytes with having so many equivalent number of sectors which are being read, right? This comes scheduling algorithms order pending accesses to tracks so that the disk movement is minimized. And finally, we need to look into the file organization that optimize the block access time by organizing the blocks to correspond to how the data to be accessed. Like one is that so-called disk access and how much block is there, what are the sector, etc., and how the file is organized. That also matters, because whether it is fitting into a particular block or it is on the overlapping blocks, then you need to access two blocks and things like that. And so like stored related information in the same or nearby cylinders, as we are talking, or more preferably in the same or nearby platters, right, within a cylinders. So that will give a better access performance, right? So data gets fragmented over time. If the data is inserted to deleted from the files, so that gets fragmented. So we need to keep a track of where the free spaces are there. So, or then maybe one reason, or free blocks on the disk are on disk are scattered. Newly created file has its blocks scattered over the disk. That can be also there, right? Once the things is writing that there are these free blocks in a particular disk, or that magnetic disk can be scattered, and that in turn fragment the file. Sequential access to the fragmented file results in increased disk movement, right? Sequential access of a fragmented file can be more increased things. So there are some systems that utility, like we also run sometimes in our systems, like laptop or PCs, that is a defragment or defragmentation tools, right? So what it will do, it will basically reorganize the data, how it is stored in the magnetic disk in a more contiguous fashion. So utilities to defragment the file system in order to speed up the file access. So file organization, record organization, and storage access. So if we look at the file organization, the data is stored as a collection of files. Each file is a sequence of record. A record is a sequence of fields, right? So this is known to us, right? Same true for whether this is a database files or any other files. It's a basically, this is the approach of what is followed. So one way of looking at it, assume the record size is fixed, right? Each file has records of one particular type only. Different files are used for different relations, right? So that is the thing. This case is easiest to implement. We will consider. So we'll see that this is the fixed length things. There can be situation where we need to look at the variable length records, right? So store record I starting from bytes n equal to I minus 1, where n is the size of the each record, right? So record access is simple, but the record may have cross blocks, right? Suppose here in this case, sorry. So if you see the amount of each record, each tuple size, so is say something like say first of all is maybe integer 8 byte and say 20 character, 28, another 20 character, another 28, and if it is so 48, and this if we have something something odd, right, like 7 byte or 5 byte and things like that, then it becomes somewhere 50 to 53 bytes, right? Now if we store as this record, then some of the records obviously may cross the record boundary, sorry, block boundary. In other sense, accessing a particular record, I may have to access two blocks because some portion is here and some portion is here. And things become more critical if there are deletion and insertion. So this keeping track of these free things, which is crossing blocks, not only track, filling up this by next insertion, etc., is also a challenge, right? So one challenge is that deletion of a record I. So what we should do, right? One is that move the I plus 1 to rest of the records. so that it is compact. So it's a pretty costly affair, right? So every time if you do and that gets deleted, and you move the records, and it database may be pretty large, so this will be pretty costly to implement, right? Rather, do not, the other way is that do not move the record, rather keep a link for the all free records on the or something called free list, right? So next time insertion is there, it takes a this location from the free list and store the data there, right? So incidentally, in our database systems, what we see that number of deletion is less, right? There are more insertion and reads rather than very frequently deleting records, right? So this is deleting 3 records and compacting, like record 3 has been deleted and then compacted. Deleting record 3 and moving the last record, right? So instead of compacting, 11 is moved there. Those all requires a lot of cost because you need to have immediately move the records, right? In this case, all the records are moved upward from 4 to 5, right? Whereas in this case, only 11 is moved to that particular location, right? Other than this, other as we were discussing, there is a thing that we can keep is a free list, right? Store the address of the first deleted record in the file header, and then you have the so every this we can keep the track of the things that where the next free list is there. So next time a new insertion is there, we can insert it to the that free list, right? So this way we can keep these pointers since they point to the location of the next record. Right. So more space efficient representation, reuse the space for normal attributes of the free records to store pointers. So additionally, you do not have any pointer storage type of things. But there are variable length records, right? So there can be several reasons for that. So one, so variable length record arises in database DBMS in for different reasons. One may be storage of multiple records types in a file. So different type, more than one type of record type. Record type that allow variable length for one or more fields, such as strings like varchar, right? So that can be a variable length. Record types that allow repeating fields used in some older data models, not exactly present day. We don't usually those are not there, but definitely these varchar or multiple record types are there. So where your variable length records then becomes another challenge. So attributes are stored in order. Variable length attributes represents a fixed size of set and length with actual data stored after all fixed length attributes, right? So that can be one way of approaching it, and null values to represented by null value bitmap, right? So that is the things that we can do. So variable length record slotted page structure. So this there that in a slotted page, the header may contain the number of record entries, end of free space of the block, and location and size of the things, right? So in case of a variable length, we need to manage it. Or there are a lot of overheads in this sort of file management, right? So records can be moved around within the page to keep them contiguous with no empty space between them. Entry in the header must be updated. So I can have this sort of a sorted page structure, right? So pointers should not point directly to the record. Instead, they should point to the entry of the record header, which actually gives the where the actual record is there, right? And how to organize these records in the files? So one popular thing is heap, right? A record can be placed anywhere in the file where there is a space, right? Sequential, store records in a sequential order based on the value of the search key. So using one of the search, using search key, like it can be the primary key and things like that. Hashing, a hash function computed on some attribute of each record. The results specifies in which block of the file the record should be placed, right? So that is the having that hashing. So that we'll see some of the indexing and hashing in our subsequent lectures. Record of each relation may be stored in separate files. In a multi-table clustering file organization, records of several different relations can be stored in the same file, right? So the motivation is that store related records on the same block to minimize I/O, right? So that can be planned accordingly. Sequential file organization. So by a search key, in this case, this employee ID is the key, where suitable for application that require sequential processing of the entire file. Right? So that is that it helps that if this type of things are based on the primary key or based on the search key, the processing is done. So deletion is a challenge everywhere. So in case of files organization, deletion use pointer change, insertion, locate position where the record to be inserted. If there is a free space, insert there. If no free space, insert the record in a overflow block. Then either case pointer chain must be updated, right? So where to points and things like that. If there is a space, you insert. Otherwise, have a additional block. So need to organize the file from time to time to restore the thing. So at the what we say back office operations, those files during the less peak hours can be reorganized, right? Otherwise, there will be a eventually it will slow down the things, right? So multi-table clustering file organization. So store several relations in one file using multi-table clustering, so that department, instructor are there. So is while storing, they are stored in a in a in a multi-table. So computer science Taylor something, and then comes that something that department this from the instructor table and the department table we are trying to store in a multiple structure. These are again they are difficult to manage because you need to keep a track that how data is stored, how it need to be retrieved. May allow some compactness, but always it is a difficult to manage these structures, right? So good for querying involving department join instructor, and for queries involving one single department and its instructor. So these are the things are it is good, but bad for queries involving only department or only instructor, or there are multiple department, multiple instructor. So those you have a other spin, right? Result in variable size records, right? So some of the things will be having larger size and things like that. So can add pointer chain to link the record in a particular relations, right? So this is also can be done, that like where the department thing comes, those are linked, and where the things where the instructor comes, whether the instruction data those are linked, right? So if there are this type of join things we want to keep, which may be very frequently accessed, then this sort of mechanism may be advantageous. So accessing storage, so database file is partitioned into fixed length storage called blocks, as we have seen. So typically 4 KB to 16 KB is there. There can be higher block size. Block size are units of both storage allocation and data transfer, right? So database system seeks to minimize the number of block transfer between the disk and this. So because the transfer is a costly affair, we can reduce the number of block access by keeping as many blocks as possible in the main memory, right? Provided your main memory do have that support. Buffer portion of the main memory available to store the copies of the disk in the block, right? So, which is in the buffer. Once the buffer is there, then how this buffer replacement or replacement policies will be there, those comes into play. And in case of disk crash or other things, what will be there. So there, once you have a buffer, there should be a buffer manager subsystem responsible for allocating buffer space in the main memory. So if there is a buffer manager, the program calls the buffer manager when they need a block off from the disk. If that block is already in the buffer, buffer manager returns the address in the of the block in the main memory. And if the block is not in the buffer manager allocates space for the buffer in the block, replace throughout some of the blocks, maybe LRU and type of policies may be followed. Replacement block written back on the disk only if it was modified since the most recent time, and that was written to the disk. Right? So reads the block from the disk to buffer and returns the address to the buffer. So the buffer is a so once we maintain buffer, so there is a buffer manager who takes care that how this accessibility of the buffer can be there. The program will request the buffer manager. If there is a space, fine, allocated. Otherwise, there will be some replacement strategies, right? And things like that. So this is a very brief about the overall overall this file organization and storage. Though this is something which are known to us, and you have read maybe more details detailed in for your computer architecture and organization courses. Okay, so keeping it is important because on at the this the major challenge in database performance is that how the accessibility is there. And as you will see that when we have query optimizations, we try to see that how this overall data load can be reduced, and what are the combinations of the means if we have that equivalent query trees, whether that primarily try to see that whether the how this data accessibility will be better. Right? So here also, as the performance largely depends on that how your data is stored and accessed in the system. So while designing large databases, so this physical storage, other than or physical storage planning is required, other than conceptual modeling and logical modeling of the things. Okay, so let us we'll have next thing on the story, this indexing of this your um, indexing and hashing uh, that will that we'll see in the next class. We'll so today we'll stop here, and we'll look into that indexing hashing part in the next class, keeping in view this that there is a physical storage included.